Hi students, this is Viswanath, chemistry faculty for NEET and IIT exams. In last class we completed first law of thermodynamics and its mathematical form. Say this is the mathematical form delta U equal to Q plus W. Now see the different cases related to this law. First one, when W equal to 0, no work is done, then W becomes 0. In that case, delta U equal to Q. That means if heat is absorbed by the system, internal energy increases. If heat is lost by the system, internal energy decreases. Say this, here W 0, W becomes 0, change in internal energy is equal to heat. Suppose heat is absorbed, delta U value increases. Heat is released, delta U value decreases. Now, next case, when Q equal to 0, adiabatic, no change in the heat energy, then delta U equal to W. Here the meaning is if work is done on the system, internal energy increases. Work is done by the system, internal energy decreases. Here work is done by the system means at the expense of internal energy, in adiabatic process, work is done by the system. See this, by using this internal energy, some work is done by the system in adiabatic process. Okay, next, when delta U equal to 0, then Q plus W equal to 0. From this, Q equal to minus W. What is the meaning? Heat absorbed by the system is equal to work done by the system. Some amount of heat is absorbed, that is equal to work done by the system. So that is expressed in this way, Q equal to minus W. Next, in cyclic process, delta U equal to 0, then Q plus W equal to 0, that equal to Q equal to minus W. Here also same meaning. Work done by the system is equal to heat absorbed by the system. Okay. So these are different types of cases. Sometimes students may get confusion. So remember them carefully. Next, multiple choice questions related to first law of thermodynamics. When work done by a system was 10 joules, the increase in the internal energy of the system was 30 joules. The heat Q supplied to the system was. So work done is given, work is given, internal energy is given, Q we should find out. Work done by the system, W equal to, by the system means what is the sign of work? Negative. So W equal to minus 10 joules. And internal energy increases, then delta U equal to positive, delta U equal to 30 joules. From first law of thermodynamics, mathematical form, delta U equal to Q plus W. Q we want, so Q equal to delta U minus W. Substitute values, 30 minus 10. So 30 minus of minus 10, then we can get 40 joules. So 40 joules of energy, heat energy is supplied to the system. What is the option? 40. So in thermodynamics, you should be very careful while answering the questions, because just with a sign difference, similar type of options are given. Minus 40 joules plus 40 joules. Here answer is 40 joules. By mistake, if you select this, you will lose the marks. So be careful when you are selecting answers. Next, a certain electric motor produced 15 kilojoules of energy each second as mechanical work and lost 2 kilojoules as heat to the surroundings. What is the change in internal energy of the motor? Options are given. Now say this, work done by the system, then what is the sign of the work? negative. So W equal to minus 15 kilojoules. Heat lost to the surroundings. So Q also negative sign here. Q equal to minus 2 kilojoules. So first law of thermodynamics, delta U equal to Q plus W, that equal to minus 2 minus 15, that is minus 17 kilojoules. So what is the option? Option A is the answer. Okay. See the next one. 10 grams of argon gas is compressed isothermally and reversibly at a temperature of 27 degrees Celsius from 10 liters to 5 liters. Calculate Q and delta H for this process. Okay. So volume change is given, temperature is given, mass of the gas is given. We have to calculate Q and delta H. See this, we know that delta U equal to Q plus W. So Q we want, that's why Q equal to delta U minus W. Here argon gas compressed isothermally and reversibly. Isothermal means delta U, change in internal energy, equal to 0. Then from this expression we can get Q equal to minus W. Here actually W, work equal to minus 2.303 nRT log of V2 by V1. But already minus is there, so minus of minus means plus. So Q equal to 2.303 nRT log of V2 by V1. Here N equal to number of moles. It is not given in the question. We have to calculate. Number of moles equal to weight of the gas 10 grams divided by molar mass of the gas 40. That is 0.25 moles. R value we should consider in calories, because in options final value is given in calories. So gas constant R we should take in calories. 2 calorie Kelvin inverse mole inverse. Temperature T equal to 27 degrees Celsius, in Kelvin 300. Initial volume 10 liters, final volume 5 liters. Q equal to, substitute the values, 2.303 into 0.25 into 2 into 300 into log of 5 by 10. So finally we can get negative value. Q equal to minus 103.98 calories. Here delta H means change in enthalpy equal to N into Cp into delta T. Here isothermal process, given process is isothermal, that means T is constant, then delta T equal to 0, then finally delta H equal to 0. So in this case change in enthalpy equal to 0. So what is the suitable option? Option A, minus 103.99 calorie, that is Q value, delta H value 0. I hope you understood this question. See the next one. Express the change in internal energy of the system when two questions are given. No heat is absorbed by the system from the surroundings, but work W is done on the system. What type of wall does the system have? No heat is absorbed. That means Q equal to 0. And work is done on the system. Work done on the system means work is positive. So it is adiabatic. Q0 means constant heat. Process takes place at constant heat means it is adiabatic process. So first law of thermodynamics, delta U equal to Q plus W. Substitute that one, 0 plus W AD. Here this is adiabatic work. That equal to delta U equal to W adiabatic work. That means wall is adiabatic wall. This system containing adiabatic wall, no heat transfer takes place. Next, second question. No work is done on the system, but Q amount of heat is taken out from the system and given out to the surroundings. What type of wall does the system have? Okay. Say this here also. No work W equal to 0 and Q amount of heat is taken out from the system and given out to the surroundings. That means Q is negative. So delta U equal to Q plus W. Here Q means minus Q, W means 0. Delta U equal to minus Q. So thermally conducting walls. Heat transfer between system and surroundings. Okay. Next. W amount of work is done by the system and Q amount of heat is supplied to the system. What type of system would it be? Work is done by the system, so work equal to minus W. Heat supplied to the system, that is plus Q. From first law, delta U equal to Q plus W, Q minus W. It is a closed system. Okay students, we'll meet you in the next class.